Hey YouTube. Well, by popular demand, I am rewriting the Arduino garden bed system for a simpler version of it. So what I have here, what I'm working on, which honestly I already completed it. This is my intro to this video. I have here is the one previously. Okay, I have I made the Arduino which has a real-time clock on it, two sensors. One was to sense how much water was in the rain barrel, so there's enough water to water the whole the plants. I don't know if you guys seen my previous video, but I have a gravity-fed watering system over my garden because I have no water in that area. The only water I have is what's collected by the roof of my shop by the rain. So anyway, and that rainwater is collected in the barrel, and there's a sensor in the barrel to tell me how much water I have. That's this one. And then this one, come on, focus. This one is the sensor that goes into your garden bed to sense the moisture in there. And this is the relay to turn on the water valve whenever the soil is dry, sensed by that one. There's the LCD and the case. This case has been out for about a year and a half, or well, since I did the last video, so it's about a year and something, and it's held up. All the clips still, they're not brittle or sunburnt or sun. It hasn't been chemically changed by the sun, so it's not brittle or anything like that. So, and this, honestly, this was a pain to keep up because the real-time clock, it was kind of flaky, but it worked fine. So the new version, I'll still use the same case. Okay, I bought these Arduinos off eBay, same ones. Okay, these are about $4 or $5 a piece, where it cost me about $6 or $7 to make that Arduino, standalone Arduino. For this, I'm gonna use this. That way I can program it when I need it on the fly. Easy peasy. Okay. So that's that. Then I bought. This is the clone. Where's the real? Oh, the real one is in here. A DF robot. Capacitive soil sensor. Because a lot of you guys complain that the soil sensor that came with this, here it is. The soil sensor that came with it erodes after a while because it's reading. Oh, come on. Here we go. What's going on here? Okay. Yeah. After a while, the electrodes they corrode due to electrolysis because the Arduino, that one, the old one, version 1, was taking reading every couple seconds and kind of kept it on, so it kind of eroded it away. So hopefully. This capacitive, it doesn't touch the soil. It uses capacitive sensing to take a sample of the soil moisture. So there's no moisture, hopefully, touching the electrodes on that. So we'll be testing that new. So other than that, these are the two new things. Here is a setup. Let me see, turn it off. Let's see if you can see that. Come on, focus. This phone. There we go. So it's sensing right now. All it is taking soil moisture, and it's sensing if it's dry, moist, or wet. And that's it. So the only parts to this is the LCD, the Arduino, the relay, the valve, and a push button. That's it. This is a 12 volt running the relay. I'm sorry, 9 volt running the relay, just for testing purposes. But at my garden bed, on my previous video, I ran 12 volts to each garden bed, and that's what we'll be hooking this up. Okay. So, the way it's going to work is, right now, I bought this plant because at Lowe's as I needed rosemary, but the soil's moist and that's why it's reading moist. There'll be instructions on how to set up your values pertaining to your soil with this capacitive, or you could look it up online. It's pretty simple code, just to get a reading, and then with that reading you could set up the values to. Let me see here. Look over here. Show you. I'm going a little fast here, but it's okay. There it is. So if my values, if it's greater than 430, it's dry, and if it's between 430 and 350, it's moist, and if it is 350 or between 350 and 260, it is wet soil. Okay. Right now it's within the code here. I'll show you because I already took it off. Within this code, you could uncomment these two lines here, and that will give you a reading right here underneath the word soil. It'll give you the value just for testing purposes. It'll give you the value between 0 and 520. I already took it off, so that's why it's not showing. That's why it's commented out here. Okay, so what I'm going to do to demonstrate it, I'm going to pull out the sensor. It's going to read dry, and then it's going to say watering. There's watering plants. And you hear it, the valve is opening. I'm going to put it back in. It's going to, after 10 seconds, it's going to read dry, moist, and it'll close the valve. Okay? And it's on that loop, so whenever it starts sensing it's dry, it'll open valve, water your plants, close it when it senses moist again or wet, and it'll keep that going. Hopefully I have enough water to keep up with the plants, but that's okay. I'll adjust my numbers so it doesn't water too often. But here's an override button. So if you're at your garden and right now you should have it set for to make a reading for every 30 minutes instead of every second like I had it previously. So every 30 minutes it'll take one reading, sense if it's wet, dry, or moist, and if it's moist, another 30 minutes will go by. So what the override button does is, if you're in your garden and you're within that 30-minute time frame or whatever, and you know it's dry, but you want to water it, you want to make sure you want to water it before you walk back into your house and have a beer or whatever, you just push the override button. I'll just push it here. I'll set system override, and it'll open valve. Make sure you, and then I have it set for 10 seconds, I think, just for testing. And after 10 seconds, it'll close and they'll continue the loop. So you'll see here, it'll close. Come on, I'm almost time is almost running out on my video. There we go. Okay, and it's closing. So that's it, guys. Hopefully I'll have this code uploaded soon, and if you have any questions, let me know. If you guys want to buy a kit from me, also let me know. We'll talk to you soon. Have a good one. Okay, now I'm going to use some Gorilla Glue epoxy I mixed it up using a little spatula, and I'm going to apply the epoxy to the sensor in the area of the exposed electronics to kind of waterproof them. So let me go ahead and do that. I'll be right back. Alright, so I got the epoxy on there as much as I can. I got the edges to close that off. So I don't know how this is going to affect the sensor. So this is just the first trial, but it's capacitive, so it should not matter the sides being blocked. It's perforated. You could feel that water could get through in there, moisture anyway. So I'm going to let this sit and dry. Hopefully it'll still work after epoxying this thing. So okay, I'll come back when it's dry. Alright, where is it? Oh, okay, it's recording. So I'm back, and on this is the Chinese-made capacitive soil sensor that I added the epoxy to. So I went ahead and attached it to the soil moisture monitor, whatever, to see if it had any effect, if the epoxy had any effects on the sensor. And I was kind of a little surprised. Here, okay, let me see if I could. This comes up on the screen, or let me turn it off. There we go, that'll work. Let's put that here. Hopefully nothing behind it will screw it up. See if that pull comes in. Oh. Alright, there we go. Okay, so I'm going to leave it here so you guys can see. But what I'm going to do, here's the original sensor that I programmed the Arduino with. Okay, it's this is a original non-Chinese clone by DF Robot. Okay, so I bought this one, and this is the one I used. Okay, let me go ahead and put that one in. I'm just going to take the one that I have the epoxy on, take that one off, and put, where's this one? Okay, that's negative. Yeah, so, oh, power supply shut down. There we go. And I'm trying to put this back on. Okay, reset it. See, that one's reading right now 494, 9% moisture, which is fine for the air. I'm touching it, get some moisture reading. Let go. 495. 512 was my highest reading, so there might be some inconsistency somewhere in here, or just the humidity in the air. So anyway, so a baseline was about 512 on that DFR robot. So I'm gonna write that down here on my notepad. 512. Now it's 4. Oop, what happened? Oh, it turned off again. I'm running on the power supply here, just a thing. I should plug it in, but it's 495.
Subscribe to my dad.
9%. Thanks, buddy.
You're welcome.
9%. Okay, so now on the Chinese, I'm going to take the original capacitor sensor off, and I'm going to put the Chinese clone on, the one with the epoxy. I'm going to reboot it. That one's reading a little higher. 554. clone 1, 554, reading negative 12% moisture, which is fine. It's okay because once you get a baseline of what each soil sensor is, you go in the program that I'll show you. It's actually commented in there where to change this value in the code, so you could interpolate between dry to wet, and it'll give you the actual soil moisture percentage. Okay, so that's Chinese clone number 1 with the epoxy. Now I'm going to put in another Chinese clone without the epoxy, so you can see. No epoxy. That's the clone. Here's again. Here's the original. Okay, so I'm going to plug it in again. Clone, no epoxy. Plug it in. Turn it back on. I need my computer on. I need to plug it in. So that one's reading 555. Clone number 2, 555, 556. Negative 13%. Okay. Clone number. Do I have clone number 3 on here? Yes. Just need the cable. Put this one back on. Alrighty. So here's the clone 2. I'm just going to take it off the plug and put in clone number 3. We'll reset it just to get a better reading. And that one's reading 502. Wait. God. Power. I had 502. Well, there we go. Here, let's just do this. I'm gonna unplug it from my power supply, my phone charger, because my computer was off earlier, but now it's not on. Plug it back in with the computer. Get constant power. There we go. 546. And that's reading negative 7%. Okay. So, on average, let's add that up. Calc. Let me zoom back out. Calc. We got 554 plus 555 plus 546 divided by 3, 551. So on average, we got 551 reading on the soil moisture sensor on the clones. So on the DF robot, we're getting a 512. So 512 is actually the correct reading that this should be reading, between 512 and 520 on the DF robot, because the voltage on the Arduino, it's a 5 volt output, but the sensor reads the analog reading from 5 volts from 0 to 123 bits. Okay, so but this is a 512. This is a 512 resolution. So anyway, if you're gonna buy the Chinese clones, you're gonna have to make sure you have to change within the code that reading. I have that reading displaying, so I'll know what it is right now. But within the code, that reading won't be in there whenever it's running 100%. So you can see, let's go back to the DF robot sensor to see it actually how it works. This is just like I said, it's just going to be just a simplified version of my original watering system, just because it'll use only, right now it's only going to be using this one sensor. It's not going to be using all the other modules like the LM393s, the two LM393s, and the clock chip, the real-time clock. It really wasn't really necessary. A lot of people pointed that out in the comments that I noticed it turned off. But anyway, so people were saying, "Hey, this can you make it a little bit more simple for some of the non-technical folks?" It's like, okay. So what I decided to do is just use. Oh, that was the other comment, was that where is it? I have one here. The other sensors. I got one right here. Hold on. Sorry.
You got this, Dad. You got this.
There we go. That these gold-plated ones are kind of crap. They actually, well, within my original programming, I had reading every second or so within the code, and that was really unnecessary because it kept this active, and electrolysis kicked in and deteriorated these things in like a matter of probably a couple weeks, honestly. So one thing was to eliminate the electrolysis thing, to eliminate that out of that. So that's where I found these capacitive sensors. That way moisture is not touching it, other than the sides. Water, we'll see. I have not tested it. We'll see if moisture will get in through the sides. I'll do one with the epoxy like I did the other one. I'll do one with have the epoxy on there and one without, and see which one lasts longest. And also within my code, I'm only going to have it measure every half hour, something like that. Take one reading and move on. So that way it's not constantly on. So here we go. So it's reading 504, 5% moisture content. Here, move back a little bit. I took my wife's little plant to do this. Move over here a little bit. See if you guys can see. Oh, no reflection. There we go. So right now, it's reading 503, 5%. And actually, she needs to water this because it's a little dry. So I'm going to put it on the line where it's supposed to. And it's reading now 466, 465, 20% moisture content. She needs to water that plant. It says dry soil. So hold on. Let me pause for a second. Okay, I'm back. It was just a second. I had to go to the garage. And I went to Lowe's this afternoon and I bought me some rosemary. And that's kind of a little better. But we'll see what reading we get off of this. Okay. See, now we're getting a reading of 360, and it says moist soil. So, and it is moist. Lowe's is doing their job. Anyway, so you can see how this is working better. Right now I have it reading every second, so you guys can see this demonstration. But I'll go back in and change it to every half hour. Now, there's a few more things I'm going to update this code. This updated version. I'm going to have a override button. So whenever it's connected to the relay, because it will still have a relay. Where's my where is it? Ah, here we go. it will still have a relay to connect the ball valve. Oh, there's a fly. Sorry, fly. Okay, so here's the ball valve. This is a brand new one because I need to add it to the other beds. It's a 3-wire. Okay, so I'll have an override. What happened there? I'll have an override switch. So if it's somewhere in between the half hour when you're out in your garden, but you don't want to come back, you just want to hit this override button, which will open the valve for, I don't know, the duration that you want it. I'm going to have default it for 30 seconds. 30 seconds or 45 seconds. So you hit that override button and it will water your plants until the next half hour reading. If you understand what I'm saying. That way, there's really nothing else to do. I don't know. I think that's it for now. So I'll keep you guys posted. Put this back before I get in trouble. And hopefully this code, excuse me, will help a lot of non-technical folks. I'll still be using the same case. This one actually came from the garden. It's been out there for over a year, and it's still in good condition, other than the glue coming off on some of these parts. Now here's the other. Oh yeah, here's the other cool thing. If you go to eBay, you can buy up these Arduino clones, okay, for about $4 or $5 each. I made this Arduino clone, okay, but you can't update this one. You have to take the chip out, put it in the Arduino Uno, update it that way, put the chip back, and it's up and running again. I spent almost $6 or $7 in parts for that. So I'm not going to use that. I'm going to use my clone. Where's the other one? Here it is. This one's already open. I'm going to use this one and put it in its place, okay? And that way I could, when I'm out there, there's an app on the phone on my Arduino on my phone that I could plug in my cable and I could update the code using my phone, okay, or laptop, whatever. It's constantly, and that way it's in there. So this won't be there, this won't be in there, this won't be in there, this relay will, along with, that's it, actually. This stuff won't be in there. But the LCD will, so I might just have the LCD in here. I'll figure that out on all that. But it'll still have the relay, because it needs it. But there we go. I'll keep you guys posted. It's a work in progress, and we'll see how it goes. Let me show you real quick on the case. See, there's no damage. It's none warping. The clips are still good. Just a little faded here. And and I actually bought a Prusa Mark III printer. It's on back order, but it'll be here. So I'm going to start 3D printing stuff, which is going to be freaking cool. And that way I can place things in here perfectly without hot gluing and stuff. It'll be professionally done. I wish this case was clear. It's kind of opaque. I wish it was better clear, that way you could see the inside better. But anyway, moving forward, and we'll talk to you guys soon, okay? Bye. Alright, I'm going to show you guys how to, if you guys get this BAC engineering valve off Amazon, where I got it. It's the model number CR, where is it? CR02? Yep. CR02, which is a 3-wire valve. This particular one, and my other ones that are on my garden bed right now, they're the same color wiring. But if you get this one, this is how it works. So red, if you don't get the instruction manual, a lot of them didn't come with it, but it's simple. Red is open, blue is closed, and yellow is the ground. Backwards, I know. So using a 9-volt, I'm going to show you guys. Since yellow is ground, just touch that there. And right now, let me see if you can see there, the valve is closed. Let's see if I can use this to show you. My helping hands here. Okay. See if I have it at an angle. See if you guys can see that. Let me see. Yeah, okay, good. So right now it's closed, and I want to open it. So red is to open. And blue, take the same red wire, go to blue. And that would close, that closes the valve. Okay? Unplug it. So that's how the valve works. So on the relay, let's do this. The relay setup, you know what? I'm not there yet. Let me, the positive wire, the power from the battery is going to go into the center connector, which it's in Japanese. So on these relays off eBay, you get them for 60 cents. It's so cheap. Okay. The positive will go in the center. If I could get it in there. This wire is so flimsy. The only thing I have around to test with. There you go. Alright, so and then the open is going to go on the left one. The close is going to the right. Okay, and then you got your grounds. We'll go there, it doesn't matter. Yep. So this ground goes to the battery, okay, and then, sorry, it's positive. Oh. Yeah, here we go. I'm looking at my notes real quick. And then that ground goes there. Okay? So the battery. There we go. That is how you set up the relay with the 12, this runs on 12 volts. I only got 9 volt works just fine for now for testing purposes. But in my garden bed, as you saw in my previous video, I ran 12 volt lines solar to each garden bed for this purpose. Okay, so that's how you wire the relay to your 12 volt source, or 9 volts in this case, and then the Arduino will control the opening and closing, turning on and off the relay. So I have not programmed that in yet. That's my next step. I just wanted to see if I could find a replacement relay, and I'll be doing that now, and I'll be right back after I program it in. Also, just a quick note: this simplified version opens up a lot of analog, few of the analog ports on the Arduino where you're able to use more than one relay. This is a dual relay board. Same concept for how to wire it up. Just wire it up for one valve and another valve. Or you could do 3. I think there's enough room. Let me see. 1. There's plenty of room for additional relays. There's other boards that have like eight relays, and I think I have not experienced any of them, but I think you can program which relay you want to turn on using one analog port out of the. But someone correct me if I'm wrong. But I have no experience with the 8 board or the 6 board relay. So far, I could do 1 or 2. That's really all I was interested in doing. So let me go back. That was just a thought I had before going back to programming. But that way, if you have 2 beds and one Arduino, you could do a dual setup. I might do that like a version 3. Not sure yet. Or I'll put in the code within the program. I'll have it commented out so you could choose if you want 1 or 2 relays within the program. I might do that. So anyway, back to programming. Alright guys, I'm back. Let's see if you can see that. I gotta get up and see if it's on the camera. See if you can see it. Nah. Zoom in a little bit. Trying to get the valve at the same time. There we go. Alright, so here's a quick demonstration. Added water in the plant. Here, let me look here. There's a sensor in the rosemary. Okay, I added water so it could be moist. And what I'm going to show you now is the sensor right now is reading 340. Let me try to do something here on the computer so you can see. All right. Let me bring it over here first. Okay. Move that away. Sorry about this. I don't have any equipment to record video of my computer monitor, but anyway, that should work here. So basically, if the soil value is greater than 430, that means it's dry. So print dry. If the value is greater than, if it's 430, if it's less than 430, God, I can't see. If it's less than 430 but greater than equal to or greater than 350, then the soil is moist. And if the soil value is less than 350 but greater than or equal to 260, then it is wet. So our value now on the LCD is within that range. It is 345, so it's wet. Let me zoom out. Okay, so it's on the loop. So I'm going to go ahead and pull the sensor out. When I do that, this will read dry soil, and then that will open for 10 seconds. That's the way I got it programmed right now. It's for demonstration. It will open for 10 seconds. I'm going to put it back, put the the sensor back in the soil. So when it, after the 10 seconds, after that loop, it will read it again. And if it's still within the dry, it'll stay open until the sensor picks up that it's wet soil, and it'll close. So let's go ahead and do that, right? I'm going to pull it out and watch this right here change to dry. As soon as it's dry, it's going to open. Here we go. 3, 2, 1. Here's this. It says moist, but I think it's because yeah, there is dry. See, it was still wet. Sensor, I guess it was still reading the sensor. It says dry, so still reading dry. 10 seconds, you'll hear it click. Still reading dry, so that's still keeping open. I'm going to do it again, leave it open. See, again, it's still open because it's still reading dry. And I'm going to put it back in. So in 10 seconds, it's going to read it. And then if it's, let's see here. There it goes. So it's closing up. I should say wet. So there we go. That's how this is going to work. I will have an override button. I'll program that next. Where if, you know, like I said earlier, if you're out in your garden and you don't want to wait the 30 minutes or whatever, however you program your program, you hit the override button and that will open the valve for however long you want it, and you can walk back in your house and have a beer. So I think that's it for now. Let me see if I got time to program the override button. Wait, let me show you the button. It's actually funny. Where did it go? There it is. You know how some toys at your big discount center have little push the button test the toy. Like here's one. So this button came with a toy that I bought for my son. I don't remember what it was off of, but I kept the button. What is it? What do they call it? Yeah, trial or. Anyway, you guys get it. So this is going to be a button. You push the button, it'll override it, open it up for 30 seconds, and then close. All right, that's it. I don't know if I'll continue on with the video after this. It's just the button. I'll program that in, and you guys will have that too within the code. It'll be commented in the code. So as you can see, all it is just the Arduino, LCD, and the relay. Nothing else. So keep it simple. Alright guys, talk to you soon. Alright, I promise, I think this might be the last time. Okay, let's put that up there. So you guys can see. Okay. Let me move the camera a little bit better this way. And zoom in. Alright, so I programmed the override button. It was a quick deal. I just had to go find my resistors. But it's just because I'm using a off button, just a regular button. I might suggest you guys to order a push button off eBay, which is nicely built. It's just a button with the resistor in it. I had to put the resistor on mine. No, that aside. So here's the full example of what works. Okay, so right now it's reading moist. The sensor is in the plant right here. Okay, I'll pull it out like last time. Here's the relay. Okay, so things out, valve opens, You guys heard it? Actually, let's see. Yep. So it'll stay open until it sees moisture in the soil. It is closing. Okay, so let's say moist plants, watering soil. Okay. Hold on. I think I messed something up here. Still reading? Yeah, it's still reading. Let's reboot it just in case. Okay, so again, God, I'm gonna have to leave this alone. I'm gonna put it back in. It says watering plants. It's closed. That should clear. I don't know why it's not clearing. I'll have to. I might have done something. But here's the push button. So you're in a hurry. You want to make sure your plants get watered. You push the push button. It open. It takes 5 seconds to open. So I programmed 10 seconds. So let's start again. Override. In the code, I have it to close them within 5 seconds, and that takes 5 seconds to open. So that's why it's closing as soon as it opens. I could change it and then redo it, but I think I demonstrated the use of the override button. Okay, 3, 4, 5, and there's close. And then it's still showing moist. It's opening up because I pulled the sensor out to read. Well, display's not updating. There it is. That's why it's screwing up. There we go. I think something was touching the battery. So stay open. Dry soil. Put it back. Moist soil. I need to fix that. That should clear the watering plants. And then override. Come on, there it goes. I might have to put a debounce or something in the code. That's it. I am done. I'm gonna fix that display issue, and then we'll call it a night. But so this whole thing's going to be 1, 2, 3, 4, and if you order the thing off eBay, 5 parts. If not, hit me below. I'll see if I can put a kit together. Oh, there it goes. Lights went off. So, if you want me to put a kit together and let me know if something you guys are interested, it'll be nicely done, of course. I'll probably 3D print it, or one of these waterproof cases will be in there. All you have to do is just plug in power, and that's it. Or if you want for your specific soil, you want to put a test code to figure out your values for your capacitive sensor. That way you know those values, and you put them in the code for your specific soil, and you're off and running. It's no big deal. It should take 5-10 minutes to set up after everything's done. Anyway, that's it. Have a good night, guys.